Hello and welcome to this lesson on factoring trinomials, although now we're going to be factoring trinomials that look like this. So the only difference between this and what we had in the previous lesson is now we have a coefficient in front of the x squared term. Before this was always a 1, now it's going to be something other than 1, and that's going to complicate our factoring process a little bit. If you could, please go ahead and pause the video and see if you could find the mistakes in these two problems here. All right, the way I usually find mistakes is by actually doing the problem and seeing kind of what they did wrong. So like, even just multiplying, like that does give you x squared. That is a minus 10x plus 3x minus 30. So it looks like they messed up a little bit in here. Maybe they like, I'm saying there's a 3 and an x, 3x, and a minus 10, minus 10. Looks like they didn't really know how to multiply it or factor it, and so they just kind of like broke it apart and chunked this in the first half and this in the second half, which hopefully you found doesn't actually work. If we were going to find the actual factors of this, let's see, factors of 10 would be 1 and 10, 2 and 5. So it'd be x and 2 and 5 and a plus 5 and a minus 2. Those are the same skills we learned in the last lesson. I'm just doing more of them in my head. I can see that the middle term is going to work out to a positive 3. I can see the last terms work out to negative 10. This is the correct factoring. Here, well, things I can see that are clearly wrong, that this one cannot be the right answer, is those two things multiplied together don't give us 9. So even though the middle terms actually work out here, this is a positive 3x, this is a negative 9x, which does give you negative 6x. That works, but the last terms don't work out. All right, so let's see for real. So we know it's going to be, well, x and x, factors of 9 are 1 and 9, 3 and 3. So I don't even know how they came up with 3 and 9, but my guess is it's probably going to be 3 and 3. To make a negative 6x, both of those 3x's here and here would need to be negative. And that actually does work out. That gives us the negative 6x in the middle here. And negative 3 times negative 3 is positive 9. So that would be our answer there. Okay, so that is what we were doing in the previous lesson. Just taking a polynomial, trinomial, and factoring it. There is no new vocabulary because it's just going to be more practice of pretty much the same skill, just a little bit harder. So let's look at it. I want to factor that. Now before, what we would do is we'd go boom, 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 list factors of that last term, 1 and 8, 2 and 4, and then figure out like which pair of these would make a 10. But if you're looking, 8 plus or minus 1 doesn't equal 10. 4 plus or minus 2 doesn't equal 10. So this doesn't just help us out now, because now we also have to worry about this first term, because my first term, that 3x squared, its factors are 1 and 3. So you go, why does that matter? Well, to get this first term, it's the first thing here times by the first thing here. So this one's actually lucky that there's only one choice. It's going to be, has to be, an x times by a 3x. That is the only possible combination that gets us a 3x squared. 1 times 3. 1x times by 3x is 3x squared. So now when you're trying to work out this middle term, you have to, this extra 3 in here kind of throws an extra little monkey wrench in the problem. So it does take a little bit more guessing. Now, to help you with your guessing. Start with the numbers that are closer together first. And if you're good at mental math, you can shortcut the process a little bit. Like in my head, I'd imagine 4 here, 2 here. And go, okay, that's a 12, that's a 2. Can a 12 and a 2 make a 10? Yes. And so I'd probably continue with that. Now, I'm going to come back to him because that might actually be the right answer. Or I'd go, okay, if I put a 2 here and the 4 here, that's a 6, that's a 4. Can that make a 10? Yes. So I'll be honest, now I honestly don't know what the right answer is. It's probably going to be that. If I plug in the 8 and the 1, that's a 24 and that's a 1. That definitely doesn't work. But what if the 8 was over here? Because now switching the order of those kind of makes a difference. 3x, 8x cannot make a 10x. So I have eliminated the 8 and the 1 as a choice. It cannot be that. So now back to the 2 and 4. Let's put something in for real. I don't actually know which one the right answer is. I have a guess. So let's go with our first choice, the 4 here and the 2 here. Okay, that gives us a 12x, and that gives us a 2x. In order to make this a negative 10, we would need the 12 to be a negative and the 2 to be a positive. So then this would be a negative, this would be a positive. And you check to make sure everything works out good. So maybe my first x times 3x is 3x squared. My middles look good. That would look good. My lasts, negative 4 times 2. Uh-oh. This sign right here is wrong. I have a negative 4 times positive 2 would be a negative 8. This was not the right thing. Okay. Well, I'm glad we worked through it. We saw that didn't work. Now, if we're gonna switch this 4 and the 2. I mean, we got to change pretty much everything in the problem, but so we're gonna put the 4 here and the 2 there, because now that gives us a different combination. That gives us a 6x and a 4x, which can still make a 10x. And to make it a negative 10, these would both have to be negative. A negative 6 and a negative 4. Which means these would both be minuses up top. And we go through the check again. We know the 3x is good. There's a negative 6. A negative 4 does make negative 10. Our middle term is good. Our last term, negative 2 times negative 4, is a positive 8. So we have officially found the correct, I'll leave them up there. We've officially found the correct set of factors that make this work. Okay, so this is the same as before. It's just more complicated because of this extra number here. Factors of 6 are 1 and 6, 2 and 3. Factors of negative 1 are 1 and negative 1. So I know one of these has to be an x, the other has to be a negative 1x. So negative 1, actually I guess I don't really need the 1. Negative x times x. There's my negative 1, there's my positive 1. If I was trying these, to do this, I would try the two numbers that are closer together first. And so let's just go through. So 2 and 3, that's a 2x, that's a 3x. Notice I'm not worrying about the signs. I don't really worry about this as a negative yet. I'm just seeing, can I make my middle term work out? To make this a positive, these would both need to be pluses, which means this would be a positive 2, and this would be a negative 3. And you go, what? Why negative? It should be plus. Well, negative x times by negative 3 is a positive 3. Now, we check everything else out. Negative x times x is negative x squared. Check. Middle terms, positive 2, positive 3 does make a positive 5. Double check. Positive 2 times negative 3 is a negative 6. Triple check. We got it. First try. There are other things we can do with that negative. This is the most straightforward way for now. You'll see later on when we're solving equations, we can actually divide by -1 to get rid of him. Okay, I'll do one more, and then you'll try one. Okay, so the only factors of 3 are 1 and 3. The only factors of 2 are 1 and 2, which makes, well, I still have four possible combinations. So let's see. I mean, I would start with I like to put the 2 one first. 2v times v. I mean, the order here doesn't really matter. The order of the next one matters more. I mean, it has to be the right combination. Like, there's only one way you can arrange the 2v and whatever this other number is. So let's see. Well, let's just try 1. 1 and 3. That's a 1v. That's a 6v. Can a 1v and a 6v make a 5v? Yes, and it's a -5, if the 6 is a negative and the 1's a positive. Now the problem with that is my last terms don't work out. +1 times -3 is not +3. Okay, so the 1 and the 3 in this combination didn't work. So we're going to switch the 1 and the 3. 3 here, 1 there. 3v, 1v. Again, I need, let's multiply better. 2v, there we go. We need our middle term to work out to be a -5, so these would both need to be a negative, which makes this a -3 here and a -1 there. So now we have our first terms work, our middle terms, -3 and -2 combines to give us a -5. Check. -3 times -1 is +3, and we have ourselves the answer. All right, so one for you to try. So why don't you go ahead and pause the video and try this one right now. I would recommend listing your factors for both of the 6's and try some combinations. I recommend trying the numbers that are closer together first. Go ahead and give it a shot. All right, so both of them have factors of 1 and 6, 2 and 3. 1 and 6, 2 and 3. But that does leave a whole bunch of possible combinations for our factoring. Now, I would try 2t, 3t here first. So I would try the 2 that are closer together first. Especially if this number here is relatively small. Good. If this number is like 18 or 20 or something like that, then I might try some of the bigger ones. All right, so I'm gonna guess the 2 and the 3. I don't know where they're gonna go. I'm gonna try it. So I'm gonna try 2 and 3. I'm just throwing numbers in to see what happens. There's a 6t. There's a 6t. No, that's not gonna get me a 5. Okay. What if I reverse them? What if I put the 3 here and the 2 there? That's a 9t and a 4t. Would that give me 5t? It could. It could. If the 9 was a negative and the 4 was a positive, because we need this to be a -5. So -9 plus 4 is -5. which means this would be a negative 9 or negative 3 here, and that would be a positive 2 there. So we think we have it, so we check. 2t times 3t is 6t squared. Check. My middle terms, double checking them, negative 9, positive 4 is negative 5t. Check. Last terms, negative 3 times by positive 2 is a negative 6. We got it. So that is the answer. So by trying those middle ones, or the ones that are closer together first, like the 2 and the 3, we got it right. I got it right in my second try. Okay, here are 2 more. Go ahead and pause the video, try them on your own right now. When you're ready to continue, hit play, and we'll go through them together. All right, so only possible combination is 1 and 5. Possible factors 1 and 4, 2 and 2. Now, this 12, as I was saying in the last problem, if this middle term is kind of bigger, it's more likely to be one of the bigger ones, but I'm not sure. So I'm going to keep going the same kind of pattern I've been doing. I'm going to try the ones that are closer together. 2m and 2m, that's the middle ones, the ones that are closer together. And then a 1 and a 5 is the only possible thing that could be in my last spots. It's the only thing that multiplies together to get 5. So there's a 2m, there's a 10m. I can get a negative 12 if both of those were the same sign. If this was a negative 2 and a negative 10, I would get a negative 12, which means boom, 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 and we double check. 2m and 2m is 4m squared. My middle terms, I'm actually just double checking the multiplication. Looks good. They do combine to give us negative 12. And when I multiply these lasts together, we do get a positive 5, which means we're done. That's it. Letter F. Only possible combination is 2 and a 1. Only real combination is a 1 and a 3. Now, one of those has to be a negative, and I'll be honest, I don't think it matters which one. So if you make it a negative 3s and a 1s, we can do that. If you want to make the 1 negative, I think we're going to get an equivalent answer. And then maybe afterwards I'll show us another way of doing this same problem. I didn't do it in the previous one, I thought about it, but maybe after this one I'll show. So then, well, we know it has to be a 2 and a 1. There's a 2s. There's a 3s. 2s and 3s cannot make a 7s. So I need to reverse the 2 and the 1. Which, if I would have thought about that, would have made more sense, because 2 times 3 is 6s and 1s. That's much more likely to give us a 7s. Okay, so let's keep going. So to make this a negative 7, we need both of these numbers to be negative, which means this would be a negative 1 here, but this would be a positive 2. Oop. Yes, yes, yes. Because negative 3 times by positive 2 is a negative 6. And now if I double check, everything does work out. Negative 3s squared. My middle terms, I'm checking the multiplication again. Okay, I'm checking the addition again. Yep. My last terms, negative 1 times a positive 2 is a negative 2. All right, so that does work. I'm going to slide him down. That is a correct answer, and we're all good. Another way you could do this is you could factor out a negative 1 first. By factoring out a negative 1, I've changed the sign of everything inside. So now all the negatives turn to positives. And then from here, I could break it down into two smaller I could just kind of do my normal factoring with just the positive dudes. So that would be a 3s, s. That would probably be a 2 and a 1, just like we had it before. This would be a positive, and this would be a positive. This is another possible answer. Even though these two don't look exactly the same, look at this, my last term, s plus 2, s plus 2. It's the same. These would be equivalent if I would multiply the negative 1 through. If I multiply the negative 1 through here, this become a negative 3s minus 1. Hey, that's what we have here. And believe it or not, there's actually a third possible answer. 3s plus 1, negative s minus 2. That would be what you get if you take the negative 1 and times by this s plus 2 term. Okay. So all three of those are technically correct answers, and it's just different. I'm not saying that one's better than another. I don't even know which one you'd more likely see. I'm kind of a fan of this one because it gives you a little bit more options. And it gets rid of that negative in front. It makes the factoring for me, I believe, a little bit easier. You don't have to worry about like this trickiness of negative 3 and positive 2 to make a negative 6. So I'm throwing it out there. I know this is the second problem like this we've seen, and I didn't talk about the first one, but I wanted to show you how you would do the problem normally. And I wanted to show you how you could do the problem trickier is not the right word. Smarter, maybe? I don't know. All right, so solving an equation. You probably know what's going to go on here, right? We're going to take each of these equations. We're going to set them equal to 0. We're going to move everything to one side of the problem. Then we're going to factor, just like we've been factoring previously in this lesson. Then once everything's set equal to 0, we're going to use that zero product property and break it down into two separate equations and solve them. That is the exact process we went through in the previous lesson and the one before that, and it's going to be the same here. So we're going to have 3p squared minus 20, ooh, I lied, minus 17p minus 28 equals 0. All right, set it equal to 0. Factor equals 0. We got some factors of 28 to worry about. Now this one is just 1 times 3. 28, we've got 1 and 28, 2 and 14, 4 and 7. So we got some factors to worry about there. So this one has to be a 3p and a p. I'm not really worried about him. Now I'd recommend trying the pair that's closest together first. Now, I think I see the right combination. I was doing a little quick mental math in my head. I said, 3 times 7 is 21. Could a 21 and a 4 make 17? And the answer was yes. So if I put the 7 here and the 4 here, pretty much just like it shows, and that was my first choice, 4p and 21p can make a 17p if the signs all work out. We've seen sometimes where it doesn't, so let's not just jump to conclusions yet. I would need the 21 to be a negative and the 4 to be a positive. So plus here, minus there, and this actually does work. There's my 3p squared. My middle terms, I'm double checking the multiplication first. Good. Good. I'm double checking the addition to make sure it does equal negative 17p. I think we're good there. And then the last terms, 4 times negative 7 is negative 28. All right, so the factoring was good. And now the solving. Using our zero product property, that was a 4. Using our zero product property, either 3p plus 4 equals 0 or p minus 7 equals 0. I'm going to solve the right side first because I can do that in my head just by adding 7 to both sides. Over here, it's going to be a fraction. I'm going to subtract 4 on both sides. 3p equals -4. Divide by 3 on both sides, and p equals a -4/3. So those are our answers. Remember, we have 2. Letter B. Now, things I see. This negative sign out front. We don't usually like him. I showed you in like 2 problems ago how we could kind of factor him out first and then kind of ignore him for the rest of the problem. Well, here we can do something very similar, except we can do even better. If I divide the whole problem by -1, which we're allowed to do as long as you do everything to both sides, watch what happens. 3x squared, positive, because negative divided by negative is positive, minus 14x plus 8 equals 0. By dividing by -1, I've essentially just said, you know what? I hate you, negative. Go away. And he's gone. And I did change the sign of all the numbers. And now we can factor without having to worry about a negative. Ain't that snazzy? Okay, factors of 3 are 1 and 3. Which is going to make this first part easy. It's got to be a 3x and an x. Has to be. Factors of 8 are 1 and 8, 2 and 4. Which means I do have some combinations I have to try. Now, mental math, or guessing and checking, we try the pair that are closer together first. So I'm going to put the 4 here and the 2 here. This gives me a 4x. This gives me a 6x. No, that didn't work out. 4x and 6x does not give us 14. Let me switch them. And put the 2 here and the 4 there. 2x and 12x. That could work if they were both negative. Because if I had a -2 and a -12, I would get a -14, which means this should be a negative and that should be a negative. And double check. 3x and x is 3x squared. I'm checking my multiplication. That looks good. I'm checking my addition here in the middle, my middle terms. That looks good. I'm checking my lasts. -2 times -4 is a +8. We're good. We got it. And then we solve. X minus 4 equals 0. Add 4 to both sides. Solution. 3x minus 2 equals 0. Add 2 to both sides. 3x equals 2. Divide by 3 on both sides. X equals 2/3. If you want, you can show the +2 divide by 3 divide by 3. All right. I've done a couple, you do a couple. Now, if that first one you're going to, we haven't even seen anything like that yet. Distribute first. Get rid of the parentheses and go from there. All right, so there's your little hint. Go ahead and pause the video, try these 2 on your own. When you're ready to continue, hit play, and we'll go through them together. All right, so if you took my advice and you distributed, you'd have a 6t squared minus 7t. I'm also going to subtract this 3 in that first step, just so I don't have to waste another step with it. So now everything's on one side and I've distributed. 6t squared minus 7t. So that's this first half. And then I subtracted this 3 over. Everything there looks okay. So we're just going to start factoring. I know there's the back number, the 3 here, has to be a 1 and a 3. The 6 could be a 1 and a 6, a 2 and a 3. So we've got some choices we have to deal with. So I'm going to try 2 and 3 first. And I know the other one has to be a 1 and 3. Maybe not in this order. Maybe not the 1 and the 3 here. It might be the reverse of that. And now that I'm looking at it, it probably actually is the reverse of this. But let's give this a shot first. there's a 3t, there's a 6t. Now, 3 and 6 does not make 7. But I think if I reverse the 3 and the 1, that gives us a 9t and a 2t, which actually could give us a 7 if the 9 was negative and the 2 was positive, because we needed this to be a negative 7, right? So we need those two combined to give us a negative. So that'd make this a negative 3 and that a positive 1. So now I double checked. 2 times 3 is 6t. Check. My middle terms, I'm checking the multiplication first. Looks good. Looks good. I'm checking my addition. Negative 9 plus 2 is negative 7. We're good. And then I'm checking my last. Negative 3 times 1 is a negative 3. We got it. Now we solve. So 2t minus 3 equals 0, or 3t plus 1 equals 0. And you solve both equations. You should have done this already. Let's see, minus 1, 3t equals negative 1, divide by 3 on both sides, negative 1 third. Plus 3, 2t equals 3, divide by 2 on both sides, t equals 3 halves, or 1.5. And that's it. We solved it. Those are the two values that we could plug in here for t that would make this side equal 3. Okay. You probably start by adding 15m to both sides. Pretty much have to. 16m squared plus 15m minus 1 equals 0. So you set everything equal to 0. You started to factor. Good news is those two, the lasts, have to be 1. There's no other possible way or combination. I don't even need to switch them. They have to be 1. So really what it's going to come down to in this problem is the first term. So are we going to use 1 and 16, 2 and 8, 4 and 4? Now, working smart, not hard, I can take a guess. If I plug in a 4 and a 4, 4m is not going to be a 15. If I plug in an 8 and a 2, 8m and 2m is not a 15. But if I plug in the 1 and the 16, 16m and 1m could give us a 15. If that one was a positive and that one was a negative, because we need this to be a positive 15. So this one's the positive and this one's the negative. Double check. 1 and 16 is 16m squared. I'm checking my multiplications. They look good. I'm checking my addition in the middle. It looks good. I'm checking my last terms. 1 times negative 1 is negative 1, and that is good. Do you see how quick that check is? But it's so very important because there's so many places in this you could make a little dinky mistake and not even really realize it. Okay, now I'm using that zero product property and I'm setting both pieces equal to 0 and solving. So m equals a negative 1 if you subtracted 1 on both sides, and 16m equals 1 divided by 16, and m equals 1/16 on the other side. So there we have it. Hopefully by now you are getting quite familiar, and this is not too terribly hard. It's just an extension of what we were doing previously. A javelin thrower throws his javelin from an initial height of 6 feet. So like, the guy's holding the javelin above his head. So here he is running. Oh, that's a weird leg. Cha-cha, cha-cha. And he has his one arm up like this, and he's going to throw the javelin. So he's throwing it from a height of 6 feet. He throws the javelin with an initial vertical velocity of 10 feet per second. That's just, we're not talking about the sideways distance. how fast up and down it's going. How long will it take for the javelin to hit the ground? All right, so let's see here. This is one we're doing together. We've got, well, the final height is when it hits the ground. So this is our final height. So that's going to be a 0. I want to know when that thing hits the ground. -16. T. That's kind of the question. How long will it take? Means I don't know T. The velocity is 10 feet per second. And our starting height, initial height, is 6 feet. So there's me plugging in all the values I know. That's a pretty awesome javelin dude, huh? There. He's missing another piece of his arm. All right. So now we do what? Well, I'll be honest with you. There's two things I can do to make this problem easier to factor. One is I could divide by -1, just to get rid of the negative there. But you know what? I can do better than divide by -1. Check this out. I'm going to divide both sides by a -2. Huh? Well, each of these values are even. I can divide each of these by 2 and get a nice, pretty whole number. So I'm going to get 0 equals 8t squared minus 5t minus 3. Smaller numbers, usually easier to factor. So you're allowed to do that with these equation dudes. You can divide by a common factor and just make each of your values smaller. All right, now let's go on and factor more. Well, has to be a 1 and a 3 for my last term. 1 and 3. This is going to be a 1 or an 8 or a 2 or a 4. Well, let's try the 2 and the 4 first. That's the one that usually works out better for us. And I'm not even going to think about it. I'm just going to throw in a 1 and a 3 and let's see what happens. There's a 4t and a 6t. Nope. That didn't work out. That's not going to give us a 5t in the middle. Okay, let's switch the 3 and the 1. There's a 12t and a 2t. Nope, that cannot give us a 5t. All right, so I've determined the problem is not with the 3 and the 1, it's with the 2 and the 4. So it's not that one this time, it's the 1 and the 8. Now, I know if I put the 8 here, that's going to give me a 24t. There's no way I'm getting back to 5, so that's the wrong spot to put the 8. Let's put the 8 here and the 1 there. So that is working a little smart. That gives us a 3t and an 8t, which could give us 5t. And to make it a -5, we need the 8 to be a negative and the 3 to be a positive. Double checking. 8t and 1t is is 8t squared. Checking my middle term, my multiplications, yes. And yes. Checking my addition, yes. Checking my last term's multiplication, yes. Okay, so we have successfully factored. And now we solve. So because this is set equal to 0, we can use the zero product property that says, well, t minus 1 equals 0, or 8t plus 3 equals 0. This right side is what I'm looking at now. If I add 1 to both sides, t equals 1. So it could hit the ground after 1 second. The other side, I'm going to skip some work. I'm going to subtract 3 on both sides. 8t equals -3. I'm going to divide by 8 on both sides. So if you've got space, divide by 8, divide by 8. T equals -3/8 seconds. So which of those do you think makes the most sense? Do you think when this dude throws the javelin, it's going to hit the ground after -3/8 of a second or after 1 second? Well, the 1 second's the right one. It's the only one it could be. You're not going to get a negative answer. There you go. So after 1 second. SECOND. There we go. That'll be a rectangle's width is 6 more than 2 times its length. The area is 80 square inches. Well, what is its length? So here's what I want you to do. If you're super confident, work the whole way through the problem before you check back with me. If you're not super confident, I'd like you to draw and label your picture, including the lengths and widths of the sides and the area. Maybe even write the polynomial you think would work, and then check back with me. And I'm going to work through the first few steps and then pause again, and so you can check your work and then let you continue. All right, go ahead and give it a shot. See how far you can get. All right, so you should have drawn a rectangle. We know the area is 80. The rectangle's width is 6 more than 2 times its length. So 6 more than 2 times the length. And the other side is just length. I mean, we don't know what the length is. We're just going to call it length. So those are my labels. If that's as far as you got, and you got even stuck there, hopefully this got you better. Pause the video and see if you can go farther. Everybody else, we're going to keep going. Area equals length times width. Plugging in what I know. I don't like doing cursive L's, but a regular L would look like a 1, so if that's as far as you got, see if you can go farther now. And now I'm just going to solve. So I'm subtracting 80 on both sides. 0 equals 2L squared plus 6L minus 80. So everything's on one side. We set it equal to 0. I'm looking at that going, well, I could divide everything by 2. I think that's going to be a good idea because there's a whole bunch of factors of 80. There's less factors of 40. So if I divide everything by 2, I'm going to get 0 equals L squared plus 3L minus 40. I just think that's going to be easier to factor. Now there's only one possible thing to give me L squared. It's going to be L and L. So I'm going to do it over here. Boom, ba-dum, ba-dum, ba-dum. So it's got to be L and L. It's the only thing that could give me L squared. Now, factors of 40. Let's see, we've got, what are they? 1 times by 40, 2 times by 20, not 3, 4 times by 10, 5 times by 8. Now my brain works in overdrive. I can see which one it is. It's going to be this 5 and 8 because they're only 3 numbers apart. So if I plug in 5 here, 8 there, this is a 5L, this is an 8L. In order to get a positive 3, we would need the 8 to be the positive and the 5 to be the negative, which makes that a minus and that a plus. And then I double check everything. L times L is L squared. I'm multiplying the middles and the outsides. They look good. A negative 5L and a positive 8 does give us a positive 3. And negative 5 times by positive 8 is a negative 40. Sweet. We done there? What was the question? What is its length? Okay, so we don't actually have that yet. We don't know what L is. But we can solve, because this is equal to 0. So either L minus 5 equals 0 or L plus 8 equals 0. Solving both, the length can be 5 inches or the length could be a negative 8 inches. It's not really a tough choice. It's got to be 5. So the length of this rectangle would be 5 inches. So this is 5, and it doesn't tell us, but this other side is 2 times the length plus 6, 16. And this area does work out because 5 times 16 should be 80. Look at that. So we found the right length that makes this all work out. In summary, how does having a coefficient in front of the polynomial change how the polynomial is factored? So that coefficient is the extra number in front, so like the 3x squared. So how does having that extra number in front change how the polynomial is factored? Well, it gives us more stuff to worry about. It gives us extra factors that we have to deal with. Like here, the 16, we had a 1 and a 16, 2 and 8, 4 and 4. We had more possible combinations. We really didn't actually have anything with a ton of combinations. There are times where, let me go back down to the summary page. Imagine you had a polynomial that was like 48t squared minus 5t plus 24. Now, this probably doesn't even factor, okay? I'm not worried about actually doing the problem. But if I was listing factors, 24 has 1 times by 24, and 2 times by 12, and 3 times by 8, and 4 times by 6, and 48 would have like 1 times by 48, and 2 times by 24, and 3 times by 16, I think. And 4 times by 12, and not 5, 6 times by 8. Imagine you had all of those possible combinations and you were trying to factor something. It makes it could be so much more difficult to do. Thankfully, most of the ones we saw weren't nearly this ugly. Okay, don't even try to factor this. I'm almost positive this doesn't factor. I just made this up, and so this middle term's probably not going to work out ever. All right. So thank you so much for watching this lesson on factoring trinomials. Until next time, toodles.